All right, here we are. Let's do a little lesson on second order differential equations. Okay, so we've talked about differential equations, but we've talked about differential equations only starting with first derivatives, right? dy dx, right, equals x minus y. Things like that. This is first order, okay? So first order, referring to the first derivative. If we have second order, that means we have a second derivative involved, okay? So to find f of x given f double prime of x, then what we have to do is we have to take the antiderivative of this 2 times, or we have to integrate twice. Now, when it gets to the plus c, because we aren't given any initial conditions here, we're not going to be able to replace the c with a constant or determine what the actual number is. We're just going to have to leave it as c, so I'll show you how that works. So again, second order, we're going to have to integrate twice. Okay? So let's integrate first by doing this. Integrate both sides with respect to x. Integrate both sides with respect to x. And of course, when we integrate a second derivative, we get a first derivative. Okay, so that's what we're going to get here on this left side. And on the right side, we're going to integrate each of these separately, and that's going to be 1/3 x cubed plus 1/4 x to the fourth. And then, yes, we do have to do a plus c. Again, so this is pretty common. This is what we've seen here so far, and no big deal, but we cannot replace the c with a number. And how do we integrate when we just have a c as a constant? Hey, that's not a problem. When we integrate a constant, like, for example, 4, and we take the integral of that, right, that's going to be 4x. So if this was c, then guess what? The integral of c is going to be cx. Not a big deal. And that's all we're going to be able to do here with this example, okay? So let's integrate again. Integrate with respect to x. Integrate with respect to x. And we are going to get out of this f. Okay, so we went from double prime to single prime to the original function. Awesome. So no problem, we're going to add 1 to each of these, and we're going to divide by the new exponent. So this is going to be to the fourth. And we're going to do 1/3 divided by 4, which is 1/3 times 4, right? Over here, we're going to have x to the fifth, and we're going to go 1/4 divided by 5, or 1/4 times 5. So hope you're seeing that. 1/4 divided by 1/5 is the same as 1/4 times 5. Divided by 5 is the same as multiplying by 1/5. There we go. So that's why I'm multiplying these, the bottom. Yeah, okay. Okay, so then, as I mentioned before, the antiderivative of a constant is just that constant with an x in there. And then we do have another constant, so we're going to make that other constant just another letter. And so be something like d. So to simplify and to finish off here, this is going to be 1/12 x to the fourth plus 1/20 x to the fifth plus cx plus d. And we would have to be given some initial conditions in order to solve for c and d, which we will do in our next example. Okay? So that's an example of what a second order is. It's really not that big of a deal, right? We're just going to have to integrate twice, and we're going to have to deal with 2 different constants as we go along. So the next example here is finding a particular solution. Now this is going to look a little scary, okay? But don't let it fool you. This is the second derivative that we are given, okay? Right here. The second derivative. No problem at all. What we're also going to be given is some information about some initial conditions. This is the initial condition of the function when f of 1 equals 1, but also we're going to be given some conditions for the first derivative, which is going to help us solve for that first c value. You'll see in a second. All right, so let's go ahead and focus on this second derivative. I'll rewrite this here. Okay, 20x cubed minus 10. So let's take the integral with respect to x of both sides. Integral with respect to x. That's going to give us a first derivative down here. And we're going to go 20/4x to the fourth minus 10x plus c. Okay. Now at this point, because I am given, you know what, I know what the x is and I know what the first derivative is, I've got some condition here, and it's right here. So when x equals 1, the first derivative equals negative 5. You see that? Or this could be written as f prime of 1 equals negative 5. So I'm going to do that. This is the f prime of 1. So this is 20 over 4 is 5. That's going to be, the x is 1 minus 10 times 1 plus c. This f prime of 1 we know is given to be negative 5. So negative 5. And I'm just going to go ahead and do another step here. I'm going to subtract this 5 minus 5, because that's 5 times 1. And I'm going to add 10 to the left side. And I'm going to get c all by itself. And so c is going to be, negative 5 minus 5 is negative 10, plus 10 is, looks like 0. So nothing earth-shattering here, right? This is just going to be a plus 0, no problem. That's okay. And so now I hope you see that this is what we have when it's all simplified and our c is included. 5x to the 4th minus 10x, and then plus 0. So here's where we will integrate again with respect to x. And what will that look like? Well, this will get us down to f prime of x, won't it? The antiderivative, or the integral of the first derivative, is the original function back. And we'll keep going with taking the antiderivative of this, no big deal. Bump that up to 5, so that's 5 over 5, x to the 5th, minus, that's a 1, so we're going to make that a 2, and divide this 10 by 2, and so it looks like this, plus, now I've already used c, so be careful here. Try not to put c again, because we're going to have two values for c. If you want to put c1, c2, you can, but I'm going to just go ahead with the d here, right? Like we did last example. Just please don't use the same c, because if you've said c is 0 here and then you come up with another value for c, that's confusing. It's bad communication. So let's make another constant. This is something different, right? Okay, so our initial conditions, as we see from our problem right here, this is literally x equals 1, y equals 1, right? That's just straight y. That's f of x. So if f of x is 1, that happens when this x value is 1 as well. So 1 to the 5th, of course 5 over 5 is just 1 is a coefficient. 10 over 2 is 5, and that's 1 squared, plus d, make sure I got all that right, 1 and 1. Okay, so I have now 1 minus this guy, and then plus 5 equals d. So 1 minus 1 is 0, so d is 5. Okay, so the second constant would be 5, and it looks like I can now finish off by saying my particular solution in this second order differential equation is going to be, where I'm going to go back from. Back from here, let's simplify these coefficients. So it's just going to be x to the 5th minus 10 over 2 is 5x squared. And then, of course, my d is plus 5. And let me double check that real quick. Okay, double checked my math here. It looks good so far. The other thing I'd like to do is maybe we should check this. Okay, let's just check. And how do we do that? Well, let's take the first derivative of f of x and see if it matches up with what we're given, right? If we've got our constants wrong, this check is not going to tell us whether we've got our c and d necessarily correct, because the derivative of any constant would still be 0, right? So if you're checking to see if your constant's correct this way, what if I had a 6 here? Well, the derivative of 6 would still be 0, just like the derivative of 5 is 0. So I can't tell if my constants are completely right here. But if everything does match up with what we're given in the question, then chances are you've done pretty good. So the first derivative here would be 5x to the 4th minus 10x, right, plus 0. Now let's just check to see. Look at this. Our first derivative was 5x to the 4th minus 10x. That checks out. What about the second derivative? Okay, well, second derivative is going to be the derivative of the first derivative. So it's going to be 20x cubed minus 10, no, sorry, that's a squared, right? No, what is that? Oh, that's a check mark, duh. Okay, so minus 10. Okay, this is our second derivative, and this is what should have been given in the question if this is going to check out, 20x cubed minus 10. That's beautiful. That's beautiful. See, that checks out too. So at least the check does match up with what we're given in the question. So you have good reason to believe that this is the correct answer, and it is. Okay? So that's your example. That's the bit of the teaching and example on second order differential equations. If you're good with the first order, we're just doing the same process twice. So shouldn't be that big of a deal. Again, yeah, second order differential equations. So If you're good with that, then please go ahead and here's the assignment. So the assignment is from the Finney text. I'm going to assign you here 357. Now the 1 to 9 is the first order that have been previously assigned. So if you haven't finished that, please go ahead and finish that. Number 68 is the second order. Just one question. I think there's ABC. Let me just, oh yeah, I see ABC here. Okay, there you go. It looks like you can check your answers there. There's the answers for you. But anyways, go ahead and do number 68 from your text as well. And then please, if you haven't been assigned this slope fields package yet, please go ahead and do this question from your slope fields package. Okay. Now, if you have gotten your slope fields package, and what I'm going to do is I'm going to let you pause the video now and attempt this question, knowing what you know, and then I will do the question in a moment here. Okay. So even if you don't have this slope fields package assigned to you just yet, you can go ahead and try this question. Pause the video, try this question. And if you do have your slope fields package, now you can do the whole package now. I've taught you everything from that package, and I'm going to do this one. All right, enough talking. Pause the video, give this one a try, and I'll do it for you in a second. All right, here we go, we're back. I'm not going to do it for you. I've just done it for you. Let's just walk through this real quick. So the answer is C. If you got the correct answer, it is C. Let me just walk through a couple things here. So first of all, when the acceleration of a particle moving along the x-axis, okay, so there's forward, back, there's acceleration, there's velocity, there's position. The acceleration function, that's a of t, that's the second derivative. Remember from back basic Calc 30 stuff? So here's your expression for the second derivative right there, okay? Now, the velocity is 25 when t is 3, so that is f prime of t is velocity, so f prime of 3 equals 25. The position is 10 when t is 1, so the position is f of t. F of 1 equals 10. We'll keep that in mind as we go through the problem. Okay, so if you take the integral of the second derivative with respect to t, and what you get here is f prime of t equals 6 over 2t squared minus 2t plus c. Now, if you plug in these values, so t is 3, when f of t is 25, you get this right here. Okay, and then when you solve for c, you get a c of 4. So from there, we'll put 4 in as our constant for our velocity function. We will take the integral again. As you take the integral of the first derivative, you get the original function. The integral of this expression is this right here. D would be our second constant value. So now we go to this part of the question here where it says that the position is 10 when t is 1. So that is t equals 1, f of t equals 10. So f of t equals 10, and then we put 1 in for t. You solve for d, you should get 6. This is the final f of t expression, the particular solution, which matches to C. All right, run that back and look at that again if you need to. Hope that makes sense. See you later. Yeah, I just made a video for my calculus class. Yeah. How's it going today? That's it.